everyone. In our previous discussion, we were able to find limits of a given function using any methods, using table of values or numerical investigation, or using limit laws or theorems. Then maybe you also noticed that we always get a limit, which is a real number. Now today, we are going to discuss about finding limit of a function which is infinite. Okay? So we start with this example. Find limit of 1 over x squared as x approaches 0. Using numerical investigation or table of values, we can determine the value of or the limit of the given function. In this case, for example, we use the values from the right of 0, that is 1, 0.5, 0.2, 0.1, 0.05, up to 0.001, and this approaches to 0. Okay, that's from the right. However, from the left of 0, we use negative 1, negative 0.5, negative 0.2, and up to negative 0.001. Then it approaches to 0. Then notice, if we substitute the value, the positive and negative values, okay, then we have a positive value of f of x. For example, if x is 1, then 1 over 1 squared is 1. If x is negative 1, then it is quantity negative 1 squared, it's still 1. Then what have you noticed? As x approaches to 0, f of x approaches to a larger value, okay? Or it approaches to positive infinity, okay? Again, as x approaches to 0, f of x approaches to positive infinity. Now, we have to remember that when we say positive infinity, an infinity is not a number. It will just tell us the behavior of these values, okay? It increases without bound. Okay, so let's verify that one by sketching the graph of 1 over x squared. Now, sketching the graph of 1 over x squared, as x approaches to 0, so we use the values from the left of 0. As x approaches to 0, notice that f of x approaches to positive infinity. Okay, that is from the left of 0. How about from the right of 0? It's still what? It approaches to positive infinity. So this graph here coincides to the values here in the second column of this table. So in other words, the limit of 1 over x squared as x approaches 0 is equal to infinity, or it is equal to positive infinity. Okay? So we have here the intuitive definition of an infinite limit. Let f be a function defined on both sides of a, except possibly at a itself. So assuming that we have a function which is defined on both sides of a, from the left and from the right, then limit of f of x, okay, the limit of that function as x approaches to a is infinity, or positive infinity, means that the values f of x can be made arbitrarily large. Okay, the function values can be made arbitrarily large, okay, by taking x sufficiently close to a, but not equal to a, close to a from the left and from the right. Okay, so that's the intuitive definition of an infinite limit. We have here important remarks, or for another notation for limit of f of x as x approaches to a is infinity, or is positive infinity, and we can also rewrite this one. We can use another notation, which means that f of x approaches to infinity as x approaches to a. Okay? Again, the symbol infinity is not a number. So, but the expression limit of f of x as x approaches a is positive infinity or infinity, we often read this one as the limit of f of x as x approaches a is infinity. Okay? The limit of f of x as x approaches a is infinity, or we can also read as f of x becomes infinite as x approaches a, or f of x increases without bound as x approaches to infinity. So that is the definition of positive infinity, and also an example of a positive um, of a limit, which is a positive infinity. Okay, so thank you so much. Hope you like this video, and for the next video we will be discussing about um, still an infinite limits, but it is negative infinity. Okay, so hope you like this video, and don't forget to share the learning that you've got from this video. Thank you so much, and God bless.